Hey, Algebra 2. Today we're going to be talking about solving log equations using the properties of logs, and we're really going to concentrate on the condensing property. So we might need to condense the equation so that there's only one log on each side to then be able to solve for our x, our unknown. So let's start off with number 1, and let's look at this one. So number 1 says that we have log base. Remember, what does this mean if they don't have a base right there? It's assumed to be 10, common log. So we have log base 10 of 2 plus log base 10 of x is equal to 1. So how can we condense this down to one log? So because it's addition, we're going to think what? We're going to think multiplication. So remember, when it's adding, we're going to think multiply. When it's subtraction, we're going to think divide. So let's condense this. So it's going to be log base 10 of, well, because it's a plus, you're going to multiply 2 times x and say that it equals to 1. So now that we've condensed this, we need to do our conversion. We're going to convert this to exponential. And to do that, we do what I call our loop-de-loop. And so we get 10. So little base 10 becomes big base 10 to the first is equal to 2x. So now at this point, we're just going to solve for x. So solve for x. So what's 10 to the first? Well, 10 to the first is 10. It's equal to 2x. Now we want to get x by itself. So we're going to divide by 2 to both sides. So those two cancel. So we're left with 5 equals x. Now, I do want to remind you, and so we need to check, oh, it's written right here. We need to make sure to check for these extraneous solutions. So that's important. Remember, you have to try to plug it back in. And if it gives you a negative, then it's going to be an extraneous solution. So let's go back up here and let's look at plugging 5 in for x. So if we plug in 5 in for that x, it's still going to be 5 and it's still going to be positive. So we are good. So therefore, our answer is x equals 5. Okay, not too bad, right? All right, let's go over to number 2. So again, this is going to be adding. So when we condense it, remember log base 10, now this is going to be x times 8. So x times 8 can still be written as 8x. So let's just go ahead and write it like that so we're familiar. So now we do our loop-de-loop, convert it into exponential, so we get 10 squared equals 8x. Solve for x. So we've got to first do 10 squared. It's going to be 100. It's equal to 8x. Divide by 8 to both sides. So we get 10 is equal to 100 over 8. Well, we can simplify that. We can simplify that by dividing both of these by 4, excuse me. And we get x is equal to 25 over 2. So we think this is our correct answer. Let's plug it back in and make sure that we don't get a negative. Well, if we put this 25 over 2 in for that x, it's not going to change it that it's positive. So it is good. We are good on that one. So no extraneous solutions. So far, not too bad. Let's see if it gets any harder. Okay, so notice that we have 2 logs over on one side and then we have another log on the other side. And that's okay, but we definitely want to condense this left side of the equation down to one log. Okay, so how do we do that? Well, let's deal with this 3 right here. What happens with that 3? Well, remember, to condense it, we've got to come back and put it as an exponent of that x. So I'm just going to rewrite it so that we can see it. X to the third minus log base 5 of 4 equals to this thing on the right, which states log base 5 of 16. Okay, so now we have that negative, and remember, what did we say about the negatives? We got to think division. So to condense this, we're going to say log base 5 of the first number is going to be your numerator, so x to the third over 4. Now remember, your log, notice that my log's not extending over to that log base 5. Okay, it is just x to the third over 4 is equal to log base 5 of 16. Okay, so now notice we have the same log base 5, on both sides. So what do we know from our quiz on Friday? We know that we can, if you have the same log on both sides, you're essentially canceling them out and setting what they're equal to each other. So x to the third over 4 is equal to 16. Okay, so now we're solving for x at this point. Well, to solve for x, I need to get the 4 to the other side. So I'm going to multiply 4 to both sides. You could also cross multiply if you wanted to here. So those go away, so we're left with x to the third is equal to 64. So 16 times 4, I believe, is 64. Okay, so let's try to rewrite this, because this is x to the third. We can't rewrite them as the same base. That just doesn't work. But can we take the cube root here? Can we take the cube root of both sides? Well, let's see. So if I take the cube root here and the cube root over on this side, well, what am I left with? Well, this cube root and this third power cancel each other out. So you're left with x equals, well, I could rewrite 64 as 64 to the 1/3, right? I technically could do that. So then, is there any way that I can write, you see how all this is coming back, is there any way that I could rewrite 64 to some base raised to the third and then raised to the third again? And why would I want to do that? Well, I want to make sure that these cancel, remember? So then what would that be? 64, how can I rewrite 64 to something equals to the third? Well, that would be 4 to the third. I could raise 4 to the third is the same thing as writing 64. So now look what happens. Well, because a power raised to another power, you have 4 raised to the 3 times to the 1/3. Well, those 3's cancel, right? When you multiply in fractions. So you get x is equal to 4 to the first, which is just x equals 4. Okay, now plug it back in. Let's look. What's a positive 4? So if I plug that positive 4 into my original equation into that x, it doesn't give me a negative. So we're good. We don't have an extraneous solution. So that's number 3. Okay, if anybody has any questions, you guys pause the video and help each other out, ask each other, make sure everybody's okay for example number 3. All right, let's move on to number 4. Okay, so it's a plus, so to condense it, I'm going to multiply. So I have x times x minus 6 is equal to 2. Okay, well, we can do our loop-de-loop here to change it, and you get 4 squared is equal to x times x minus 6. And now we're solving for x. Well, we got a lot going on here. Let's see what we got. We got 4 squared. We know that that's 16 is equal to, well, I probably need to distribute my x there. So I get x squared minus 6x. Okay, so what are your thoughts at this point? When I'm seeing this like squared, I'm thinking I need to get everything to one side so I can have it something like that whole quadratic equal to 0. So then maybe I could, what are y'all thinking? I'm thinking we've got a factor. Okay, so that's what I'm thinking on that one. That star's not a good one. Let me try that again. Star. Okay, so let's move the 16 over. So if we do that, we get 0 equals x squared minus 6x minus 16. So now everything's to one side. And now I can think, let's factor. So what are factors of 16 that are going to subtract to give me a negative 6? 8, negative 8, positive 2. Now again, we're trying to solve for x. So we have to set each one of these binomials equal to 0. And then we solve. So we get x is equal to positive 8 and x is equal to a negative 2. So x is equal to negative 2 and 8. But we always have to check for extraneous solutions. So remember, check for ES, so extraneous solutions. Okay, let's take this first one, negative 2. Let's go to your original. I'm going to change my highlighting color because it would be the same. So if I were to plug this negative 2 into my equation, look what it would give me. That would give me a negative 2, which we can't have. Remember, those ofs can't be negative. So therefore, this negative 2 is an extraneous solution. So we cross it out and we put ES next to it so that I can tell that I got it as an answer, but it doesn't work for part of our problem. Now let's go look at that 8. So if I plug 8 into that x, we're good. So let's make sure that it works over here too. 8 minus 6 still gives me a positive number. So 8 is our only solution there. Okay. You guys pause if you guys have any questions. Ask each other, help each other out. And then let's move on to example number 5. Okay, so here are those ln's again, those natural logs that I told you about, and they're just ln. So ln and e go together. So in this example right here, this is not going to be something that we need to worry about much, but it does come up in our next problem. So we'll talk about that when we get there. So right now, though, go ahead and see how you can condense down to 1 ln. So we're treating it the same way we do a log. So because it's minus, we're going to say 2 divided by 3x plus 2 equals 1. Okay, it does come up on here because if we were going to try to do the loop-de-loop here, it's going to be confusing. So if you have your graphic organizers, do you guys have those with you? If you do, go ahead and pull them out right now because I want you guys to look at this. So I want you to pause the video real quick and I want you to write down this E problem right here. So when we're condensing, solve with condensing, split it up, and one we're going to do with an ln and E. So the first thing that we need to do is we need to condense. Okay, then look here, this is the important part right here. This ln, we're going to kind of treat it as log base E. I know that sounds funny, but anytime that we see that ln and we're trying to change it to an exponential, we're going to change it first to a log to the base E, and then we're going to do our roundabout, and then we might use a calculator, and we'll see about that in a minute, to solve. So go ahead and write down those 4 steps. That's really the important part right now. The thing that's highlighted is the most important. The ln is equal to the log base E, and you'll see why that comes in handy in just a minute. And then here's an example, and go ahead and pause, write that down on your green sheet. Your green sheet should be in your folders. If not, they're somewhere around your folders or maybe on the desk. So pause, stop, grab them, write them down. Okay, so let's go back over here to this problem. So remember, I just said we're going to take our log, or ln, and we're going to change it to be log base E. So let's do that right now. So instead of having this ln right here, I'm going to change this to a log base E of 2 divided by 3x plus 1 is equal, 3x plus 2 is equal to 1. So now when we go do our roundabout, look what's going to happen. It's going to become e to the first, so e to the exponent of 1 is equal to 2 divided by 3x plus 2. All right, so we're still trying to isolate this x right here. So to do that, we need to be able to get that 3x plus 2 out of the denominator. So this is what I'm going to do. I'm going to go ahead and put over 1, and I'm going to cross multiply. So when I do that, e to the first is just e, just like anything else. So you get e times 3x plus 2 is equal to, cross multiply over here, 2. Okay, so I know it still looks a little funky, but remember, we're trying to get that x out of there. So I'm going to go ahead and I'm going to distribute this e to both of them. So treat that e just like as a variable, like if it was pi, when you did geometry, you're just going to keep it as e as long as you can. So we get 3 xe, or let's write it like this, because we're trying to isolate that x, 3e, x plus 2e equals 2. Okay, so I want to go ahead and move this plus 2e to the other side, so you need to subtract 2e. So we get 3e x is equal to 2 minus 2e. Okay, so I'm not done yet. I'm going to have to move this up here, so hold on just a second. See if it'll do it for me. Okay. Okay. So now I still want to isolate that x. So this 3e is in my way of doing that. So how can I get that to the other side? Because it's being multiplied, I can multiply by 3e or divide by 3e to both sides. So this 3 cancels, these e's cancel, so I'm left with x equals 2 minus 2e over 3e. Okay, so I know you might be wanting to cancel these e's, but we can't do it. And why can't we do it? Well, we don't have an e with that 2. Remember, if we're going to divide out anything, simplify anything, they have to all 3 have them. If not, we can't do it. So you can leave it just like this. So here's one way to write it. Another way to write it would be to split them out. So you could go 2 over 3e minus 2e over 3e. And now you could split these or cancel these if you wanted to. Well, you should in this case. So then another way that you could write your answer is e equals, or x equals 2 over 3e minus 2/3. But this to me looks kind of sloppy. So I just leave it as this box answer. There's no reason, unless it's multiple choice and it does this for you, but typically you just see it left just like this. Okay? So right now we're just solving, we're not using our calculators because there is an E button and we could put this in our calculators, but I'll show you that when I get back. Okay, let's look at this other one. Okay, again, we're subtracting here. So we need to rewrite this as ln of negative 3x minus 1 over 7 equals 2. Now remember, we're going to change that ln. We want to rewrite that as log base e. So that's all we're doing is rewriting it. Minus 3x minus 1 over 7 is equal to 2. Now we're going to do our loop. And this is going to become e squared is equal to negative 3x minus 1 over 7. Okay, this time, trying to isolate that x. I'm going to get that x by itself. So again, I'm going to go and put this over 1, and then I'm going to cross multiply again. So I get 7e squared is equal to negative 3x minus 1. Now this one might be a little bit easier because we're going to add this 1 over. Again, we're trying to isolate this x. So we want to get that one by itself. So we get 7e squared plus 1 is equal to negative 3x. And now we're just going to divide by negative 3. Oh, I forgot my 1. Negative 3. So those negative 3's cancel, and we're left with x equals 7 e squared plus 1 divided by negative 3. Okay, I never like my negatives on the bottom here. It just looks bad. So we're going to just change all the signs. We're really multiplying everything by negative 1. So it just changes all the signs. So we get x equals negative 7e squared. Change the negative, the positive 7e to a negative 7e squared. Change the positive 1 to a negative 1 over negative 3 to a positive 3. And that is our answer. Okay, these ln's were a little bit tougher, a little bit more challenging. If you can remember this, that every time you see an ln, you're changing it to a log base e, that is going to be tremendous help for you. So on this back page right here, there are 8 problems that I would love for you to start doing right now in class. You have 8 problems to do, and they're due for homework if you don't finish in class. But right now, I think you should have plenty of time because this is 25 minutes long so far. So you have a good while to do that. You might want to help each other on 7 and 8. They're going to be the ones that are a little bit more challenging. 7 might not be so bad because, well, let's look at it. Look at 7. We're condensing it down so that we have an ln on both sides, so then they end up canceling. So that might not be too bad, but 8 is going to be where you're going to condense it down to 1 ln, and then you're going to need to change that to log base e, and then do your roundabout. So you're going to have an e for sure in number 8 in your answer. Okay, don't forget, check for extraneous solutions, and I will see you tomorrow.